MySQL is one of the most popular SQL databases, probably because it's free and it's easy to use. So in today's video, we're going to take a look at how we can write SQL commands and how we can manipulate the MySQL database. So before we get started, if you need installation instructions for MySQL, I've already created a video on it. You can go and check it out in the cards above. I will link it up there. Otherwise, let's go ahead and get started writing these SQL commands. Now, if you don't know anything about databases, there are two main types of databases. We have the SQL database, and then we also have the NoSQL database. And the one that we're going to be working with today is the SQL database. Now, a SQL database is any database that is going to use the SQL language, the structured query language. This is the language that is used to manipulate SQL databases such as MySQL. And another thing that SQL databases have in common is that all of the data is stored in a table-like structure, and we'll see how that works here in just a little bit. But first, we need to go ahead and create our very first database, because we can actually create multiple different databases and we can manipulate each one of them one at a time. So we just need to create our first database. So to do that, we could say create database, and then we need to give this database a name. So we could say this is the playground database. And we can run this file up here by using this, and this will execute the current line that our cursor is on. Or we could use this command, which is going to execute the entire file. Generally, I just use the command that executes where the current cursor is, because a lot of times I have other stuff in there that I don't really want executed at the moment. So I'm going to go ahead and execute that. And you can see over here at the bottom, we have this action down here at the bottom that says create database playground. And we have this little green check mark. That means everything is good, that we created that database. And now if we go ahead and we refresh over here, you can see that we now have that playground database that's been created. And if we want to, we can actually create another database as well. So we could say create database test. And we got to make sure that we put a semicolon at the end of every single line. That way that MySQL knows where the line starts and where the line ends. So we're going to put our cursor on there and we're going to run that line. And again, you can see we got that create database test with a green check mark down here. And it says 1 rows affected right here. So we can go ahead and we can refresh over here. Now you can see that we have the playground database and we have the test database. Now we can also delete databases as well. So we can say drop database, and then we can specify the name of the database that we want to drop. So maybe we just want to drop that test database. So we can say test, make sure we add our semicolon there, and we can execute that. Now you can see over here that the test database has been dropped and it is no longer in our schemas list over here. Now we can also see all of the databases that we have. So I'm going to go ahead and I'm going to bring back the test database for just a second, but just by running that create database line. And if we refresh, of course, you can see that the test database has returned. Don't think this is the exact same database, because the last database that we had was dropped, meaning that everything was deleted. It is no longer existing. We just created a brand new one. So we can go ahead and say show databases. And if we run that line, databases with an S at the end, and if we run that line, you can see all of the default stuff here from MySQL, and then you can see that playground database that we created here and that test database that we created here. And if I go ahead and drop that database, and then we can show databases again to show that we do not have that test database anymore. Now, before we can actually start writing database commands, we need to specify that we are going to use a specific database. Even if there is only one database, we still need to specify that that's the one that we're going to use. So down here, we can go ahead and say the use command, and then we can specify the database that we want to use. So we're going to specify that playground is going to be the database that we want to use, and then we can go ahead and execute that command. Now you can see that this is expanded and the playground database name has been bolded, and that bolding is just a visual reference to show that this is the current database that you are using. So any commands executed is going to be executed against that specific database. Now I'll just go ahead and I'm going to zoom in here just a bit so it's easier for you to see what we're doing. But now that we have created our database and we are using our database, it's time that we can start manipulating the database. So a good starting point for this would probably have to be to create a table. So to do that, we can go ahead and specify the create table command, and then after that we can specify the name of the table. So let's say this is maybe a users table, so we can specify the name of users, and then we can follow that up by opening and closing parentheses along with our semicolon at the end to denote the end of the line. Now in between these opening and closing parentheses, we're going to specify two things. We're going to specify the name of the column, and we're going to specify the data type of the column. So inside of here, maybe we want to create three columns. Maybe we want to create a username column, a age column, and a password column. So we can go ahead and specify the first column is going to be username, and then we can specify the data type as a varchar. And then a varchar is just like a string. It's basically the same as a string. And then inside of the opening and closing parentheses, we could specify the length of this varchar. So maybe a good length would be 100 characters long. And then we can put a comma at the end of that to comma separate everything inside of here. Now after that, we're going to specify the age column, and this can be any number data type. I'm just going to go with the standard int data type. And then after that, we're going to add the password column, and we're going to specify again that this is going to be a varchar, and let's say this is going to be a max length of, let's say 300. That way we give plenty of room for a password so we don't run out of space for the passwords. Now this is going to go ahead and create our table. So as long as our cursor is somewhere in here, we can go ahead and run the execute command where the cursor is at. And if we do that, we can see down here that we got a green check mark here that we created that table. It says 0 rows affected, but there wasn't any rows to begin with. Now to see that table in our database, we have actually three different options to choose from. Now the least used one is going to be show columns from users. So that's going to select that table and it's going to show the columns from that table. And if we run that, we can see that we have the username field with the type of varchar 100. Then we have the age field with the data type of int, and then of course the password with varchar 300. Now there's a shorter way to do this. We can actually say describe users. And if we run that, we are going to get the exact same result with showing all of the different columns inside of our table. Now there's an even shorter way that we can do, and this is my favorite one of them all. So we can say DESC users, just like that. And it's a shortened version of the describe command, the DESC command. And we can go ahead and run that, and that is going to be the exact same thing. And these are all three different ways that you can do the exact same thing of showing all of the different columns inside of your table. Now we can also, just like with the database, we can also drop the table as well. So we could say drop table, and then we can specify the name of that table. We can specify users, and if we run that command, we're going to see drop table users. It says 0 rows affected, but we got a green check mark here. Now let's see what happens if we run the DESC command. We're going to get an error. Table playground.users doesn't exist. So the database.users, the users table, no longer exists. So we can go ahead and recreate that table right here just by running this command here. Now, again, we can go ahead and see all of the columns inside of that users table that we just created again. So drop inside of a database or inside of SQL is going to be basically a delete term. It's going to say delete this whatever. So if you want to delete a database database or a table or whatever, you're going to utilize the drop command, and that's going to specify to delete something. Now this table right here is actually a very simple table. We can actually do a lot more with it whenever we create the table, and this includes creating constraints. So let's go ahead and just drop this table by running the drop command, and we can go ahead down here and create a brand new command to create a table called users. And then inside of here, we're going to have probably 4 or 5 different columns. So the first column that we want is going to be the ID for that specific row. So whenever you are utilizing a database, you may have millions or even billions of people or rows inside of your database. And you want an easy way to be able to easily identify each user, no matter where you are at inside of your application. So maybe some cases you need to just grab the name of the user, or you just need to grab the age of the user or something like that. And an easy way to keep track of that is to keep an ID for each specific row or each specific user that we create. So we can actually create a user ID column, and this of course can be named whatever you want, but I'm going to call it user underscore ID, and this is going to be an automatic ID that is automatically created whenever we create a new row. So the way that we can do that is first we need to specify the data type. So we're going to say this is going to be an int data type, and then after that we can specify the constraint. This is going to be an auto increment. Now what this does is just going to automatically increment every single time that you insert a new row. So whenever we insert the first row, it's going to be 1, and it's going to be 2 after that, and 3, and so on and so forth. And this will automatically create unique IDs going from 0 all the way up to however many, so that way you can easily uniquely identify each individual row. And this is actually a very common practice to see in a production environment. Now we can also specify that this is going to be not null. So we need to make sure that this never has a null value. So this statement right here will prevent anything from not being added to this column. So we will always have something inside of this column no matter what row we're in. And now another constraint that we can utilize is a primary key. This is the main identifier for that specific table, and generally it's on something like the ID for that table. So we can specify this in actually 2 different ways. We can set the primary key right here in line like this, and this will give us that this is the primary key for this table, or we can specify it down below and we can say primary key, and we can pass in the column that we want to set as the primary key. We can say the user underscore ID is the primary key for this table. Either way will work perfectly fine. Now let's go ahead and create our username column as well, and this is going to again be a varchar, and I'm going to set this to varchar 100, and again we want to make sure that this is not null, so we can specify that constraint. Then after that, maybe we want a name, so we can specify the name, and we're going to say this is going to be a varchar, and let's say this is going to be 100 length as well, and we want this to not be null as well. And then we also want a password, so we're going to say password, and we can specify that this is going to be a varchar of maybe 300 again. And let's just go ahead and add an age in here as well. So we'll add the age, which is going to be an int, and then we can specify the not null constraint here as well. And we just need to add a comma here so we can denote that there's something coming after this, and this is going to be our new table. So if we want to run through this real quick, our user ID is going to be an automatic ID that is given to us whenever we create a brand new row. This is going to be automatically incremented from 1 to whatever number is next. And then we want to make sure we're telling it that this cannot be null. Now we also are specifying that this is going to be the primary key down here. So we're saying that the primary key for this table is going to be the user ID column. Then we have the username, which is again a varchar of 100 max length, and we're specifying that this cannot be null either. Then we're giving a name again, which is varchar 100, and again we're specifying this cannot be null either. And then of course we got the age, and then we got the password here as well. So let's go ahead and create our table. So if we run that, we can see that we got a green check mark that our table was created. Now we can go ahead and desc users, and we can see now that user ID column here, which is an int, and then you can see where it says null right here is no, and then it says key is PRI. This is just basically saying that this is the primary key for this table. And then extra over here has got auto increment, basically saying this is going to be automatically incremented. And then everything else is here as well. Now the primary key is a unique identifier for each record inside of the table. So any record that we create is going to be a unique identifier for that row inside of that table. So knowing that, we really don't need to have this not null constraint here. This is going to be done for us by being the primary key. And we can only have one primary key per table, but we can have a combination of one or multiple rows inside of the table that make up the primary key. So in this case, we're just having the primary key be the user ID right here. This is the unique identifier for this table right here. So this is going to be our primary key column. Now we also have another type of key, and this is called a foreign key. Now a foreign key, what it does is it links one table to another to its primary key. So let me show you how this works. So I'm just going to go ahead and create a new table real quick, and this table, let's say this is going to be the posts table. So whenever we have a bunch of different posts, you always have the user and the username along with maybe a user image as well to show what was that posted that post. Well, we can easily reference back to this users table and say that this specific user was the one that made this post. So an easy way to do that is through a foreign key. So we can go ahead and say post ID is going to be the primary key. So we're going to say this is an int data type, this is going to be an auto increment, and this is going to be the primary key for this table. I'll just do it in line right here like this. Then we'll have the post, which is going to be a varchar, and let's say this is, I don't know, 3000 in length, and this is going to be not null. And then we can specify that the user underscore ID is going to be an int and is going to be not null. And then we can specify the foreign key. So we're going to say foreign key, and we're going to say the foreign key for this table right here is going to be the user ID column. So we're going to specify the foreign key is user underscore ID, and then we're going to say that this references the table name, so it's going to be users, followed by the column inside of that table, so it's going to be user underscore ID. So the foreign key in this table is going to be the user ID column, so this right here references this, and then we're going to say that it references the users table up here with the user ID column. So it's going to reference this column right here. So the foreign key is basically going to create a relationship between this table and this table. And then the users table is going to be what's considered the parent table, and the post table is going to be the child table. And then that link will be enforced so that we always have a user for each one of our posts. So if we don't pass in a user ID for whatever reason, it's going to reject it and is not going to allow that post to be posted. Now we can also alter the tables inside of our database as well. So we can change all of the columns, the names, and the constraints that they all have as well inside of our database. So let's say I forgot this password right here. I forgot to add the not null constraint to it. So let's go ahead and add that real quick. So I'm going to go ahead and say alter table, and then I'm going to specify the table that I want to alter. So it's going to be the users table, and then I want to modify the password column, and we are going to set that as a varchar, and I want to update that as well. So maybe we want to set this as a varchar 400 rather than 300, and then we also want to add that not null constraint, so that way we don't ever get a password that is null as well. And if we go ahead and run that, that should give us that new updated table. So we can go ahead and say DESC users. Now if we take a look at users, we can now see that the password field is a varchar 400, and now we have that null column is no, so it cannot be null anymore. Now we can also add new columns to the table as well. So we can actually use the exact same command, alter table, and we can specify the users table. Then we can say we want to add a new column, and then maybe that new column is going to be an email column, which is going to be a varchar, we'll say 150, and we want that to be not null as well. And let's say that we want to include that email column right after the username column. So if we were to run this right now, it would insert it at the end, but we can actually specify exactly where we put this email column at. So we want to put the email column directly after the username column. So we can just say after username. And now if we run that, we should get an okay success down here. And let's go ahead and run our describe command. And you can see right here we have user ID, username, and then we have email here, which is directly, of course, after the username column. And of course, it is that varchar 150, and it has that not null constraint on it as well. Now, we can also add a check constraint to a table as well. And basically, what a check constraint does is it basically just checks a condition to make sure that it passes that constraint. And if it does, then it will be allowed to be inserted into the table. And if it does not, then it will be rejected and it will not be allowed to be inserted in the table. So let's say we're making maybe an adult site. So we want to check to see before we insert the user that the user is actually over the age of 18. So we can easily do that just by adding a check constraint. So let's go ahead and drop the table users real quick, and we'll go ahead and add a check constraint to the users table. So we could say check, and then inside of here is going to be our constraint condition. And don't forget to add our comma right there. Now we can go ahead and add our condition so we can check to see if age is greater than or equal to 18. And if that condition is met, then the value will be allowed to be inserted. The new user will be allowed to be inserted into the table. But if it is not met, so it is under the age of 18, then this is going to fail and it's going to reject that insertion. So it will not be inserted into the table. But now that we have completely crafted our very perfect table for our users and our database, now I think it's time to start inserting some data so that we can start filling up this table. So we can head down here and we can say insert into, and we can specify the table that we want to insert something into. So it's going to be users. And then we need to specify all of the columns that we want to insert something into. So it's basically going to be everything except for the user ID. So we'll start with username, and everything is separated by commas. So we can say name, age, and password. Then we can specify values, and we can specify all of the different values. We can specify one value, or we can specify however many values we want, as long as we have everything for all of these columns that we're inserting into. So we could say our first value's username is going to be Tim, sure. And we're going to say the name is going to be Tim. The age is going to say 45, and let's say the password is just going to be a string of random characters. Now we can run this and we can just insert this one line, or we can insert more. So we can comma separate this, and we can add another one here if we want. So we could say Jimbo is going to be the username for the second one. The name we'll say is Jim. Then the age is 19. And we can say the password again is a random string of characters. Now we can go ahead and add our semicolon at the end here, and we can go ahead and run this. And I need to create the table first because I never did that. Now we can go ahead and insert everything in there. And we can see we got a green check mark down here with the insert command, and we inserted those 2 rows. It says down here 2 rows affected. Now there is another way that you can insert data into a table without needing to provide this, but in most cases it's not going to work because you have to provide a value for every single column inside of the database, and that includes this right here, the user ID column. And we do not actually want to provide a value for user ID because that's going to automatically be incremented and that's going to be automatically tracked for us. So we don't want to provide a value for that. So that would not work for this specific table. But maybe we have a small table. So let's say create table, and we're going to create a table called maybe person. And let's say the name is a varchar 100, and we have a password field here as well. And we can say this is varchar 400. And let's go ahead and add our semicolon there, and we should be able to insert that table or create that table. And it looks like we got our green check mark. Now, if we wanted to insert a new person, so we could say insert into person, and we could just specify the values of maybe it's Kyland and a string of random characters. And that will work perfectly fine because we just have those 2 fields and we are providing a value for both of those fields. So if we add our semicolon and then we go ahead and run that, now we can see down here that we did have that successfully inserted. But this, of course, is something that you will come across, but it's a lot less common than something like this where we provide the columns and then the values for those columns, just simply because we usually don't have tables that look like this. Now let's go ahead and see how we can select data from a table. So if we wanted to select data from the users table, that data that we just entered here, we can go ahead and say, we can say select star from, and then the table name. So we can say users. And then if we go ahead and run that, you can see that we've got both of those rows that we just entered right up here. We can also select from that person table as well that we created. So we can say select star from person. And if we run that, you can also see the name and the password values that we stored when we ran this command right here. Now, to break this down a little bit, we are going to say select something. So this something right here is going to be the columns that we want to select. So this is going to specify the columns that we want to pull from that table whenever we run the command. And then we're going to say from, and then whatever table we want to pull it from. Now I said star here because this is basically saying pull all of the columns from that specific table. And we could specify specific columns. So if we just wanted to get maybe passwords, we could say select password from users, and if we run that, we can get everyone's password. And we can also select multiple ones as well, as many as we want really, just by separating them by commas. So we could say select password, and we could say select username, and we could say select age from users. So we're going to select the password, the username, and the age columns from the users table. And if we run that, we get password, username, and age. All those columns are selected from that users table. Now we can actually pull columns from a table, and we can actually give them an alias whenever we pull them. So we could say select username as users, and we could say select password as all passwords from users. So if we go ahead and run this, we are going to see that we get the users column and the all passwords column. Now this isn't actually changing the name of the columns on the tables themselves. It's just changing the names of the columns whenever we pull them. So username is going to be users for this request, and password is going to be all passwords specifically for this request as well. And if we actually take a look at our table, we can see that nothing has actually changed. We've still got the username column, and we've also still got the password column. It's just for this one specific request, we are aliasing the username column as users, and we are aliasing the password column as all passwords. Now this is very helpful for things like joins, or if you want to pull a bunch of data for maybe a spreadsheet and you want nice headers instead of detailed headers, this would be a good option for that as well. Now so far we've just been selecting everything from our tables, but in many cases you don't want to select everything. You only want to select what you actually need. So we can actually add another keyword on here to add a condition to be checked whenever we are selecting things. So we can say we're going to select star from users, and we can say where, let's say user underscore ID is equal to 1. So if we do that and we run that, we're only going to get that column or that row where the user ID column value is equal to 1. So let's go ahead and add a little bit more to our database here. So I'll just run this command a few times, and we'll go ahead and just select everything to see what we've got in our database. So if we run select everything from users, you can see we've got 10 rows or 10 entries with our user IDs ranging from 1 to 10. Now, if we wanted to select a specific one, maybe we wanted to select only the first 3, we could say select star from users where user underscore ID is greater than or equal to 3. So we could say select everything from the users table where the user ID is greater than or equal to 3. So it's going to just select the first 3 for us. And that is actually backwards. So where user ID is less than or equal to 3, now if we run that, now that's going to give us those first 3 values from our database. Now we can also update things in our database as well. So we could say update from our table, so users, then we could set, let's say username equal to, let's say Tommy, where user underscore ID is equal to 6. So if we run that, now the user with user ID of 6, their username should be updated to Tommy once we run this. So we got a green check mark saying that we're all good. So let's go ahead and select everything, and if we find user ID 6, we should see that user ID 6 username is now Tommy. Now we can also delete things from our database as well. So to delete something, we could just say delete from users, so the table where user underscore ID is equal to 3. So user with ID of 3 should be deleted once we run this command. And we got the green check. So let's go ahead and check to make sure that was deleted. So we've got user ID 1, user ID 2, and then we've got user ID 4. So user ID with 3 has been successfully deleted from our database. Now the last thing that we're going to talk about today is we are going to talk about the logical operators. And these are the and, or, and not logical operators, just like we have in JavaScript. Now, these work very, very similar to the ones in JavaScript, so let's go ahead and get started working with the and logical operator first. So the logical operators can be used inside of the where statement. So let's say that we want to select a range of things between 2 and 7. So we could say select star from users where user underscore ID is greater than or equal to 2 and user underscore ID is less than or equal to 7. So it should select the range from 2 to 7. So if we go ahead and run that now, we should get everything from 2 all the way to 7. So we got 2, 4, 5, 6, and 7. Remember, we deleted user ID 3 right here in the last statement that we ran. But this is how you can use the and logical operator. And just like I said, it works very similarly to JavaScript and many other programming languages as well. We just use the and keyword just like this. Now we can take a look at the or operator, and it works, of course, very similar to JavaScript, but not exactly the same. So let's say we want to select star from users where user underscore ID is equal to 4 or user underscore ID is equal to 8. So if we run this right here, we're going to get both of those values because both of those exist and both of those return true. Now, if we gave it an out of range value, so maybe a 99 here, it's only going to return the very first one because we don't actually have a user ID of 99. So we did get the user ID of 4, but we don't have a user ID of 99, so it returned just the 4. But before, it gave us both of those values, and that's something that's a little bit different from JavaScript, because if we were to run something similar in JavaScript, it would just return the first one that became true, and it would ignore the rest of them. But here it's going to return everything that is true. And now the last logical operator is the not logical operator. And this, of course, again, works similar to the one in JavaScript. So we can say select star from users where user underscore ID is equal to 5, and we're going to say not user ID is equal to 5. So we're going to put that not before the conditional check, and then if we run that, we're going to get everything except for that user ID of 5. And that is about it for the basics of the SQL language and MySQL. Now, there is a lot of other stuff that we didn't go through today, so I encourage you to check out the documentation. I will link that down in the description down below if you want to go and check that out. Otherwise, we did go through a lot of stuff today, so if you have any questions, leave them down in the comments section down below. I'll answer any questions that you have. Otherwise, if you did like the video, make sure you slap a like on it. Check out the full playlist, link is right down there. Make sure you subscribe, and I will see you in the next one.